Good morning, afternoon, or evening. How y'all doing today? Welcome back to Moro's Math Corner. Today we're going to learn how to model and solve word problems involving rational expressions. So let's get right to it. Please remember that the goal of any equation, regardless of its difficulty, is always the same. You want to solve for the variable in question by isolating the variable. Also, please remember that a ratio is the quotient of two quantities and can be written in three forms. You have A to B, A colon B, or A over B. Please remember that a ratio is basically a fancy fraction. So we're always going to use the A over B format to solve and work with it in math. Also, please remember that a proportion is formed by two equal ratios. A proportion is an equation of the form A over B equals C over D, where A, B, and C are terms of the proportion. The terms B and C are called the means of the proportion, and the terms A and D are called the extremes of the proportion. So let's go back in time and remember how to solve proportions in the first place. In order to solve proportions, regardless of how complicated they are, if you have a ratio equal to another ratio, you're simply and literally going to cross multiply and solve. So x times 105 is 105x, and that's going to equal 5 times 63 is 315. The relationship between the 105 and the x is multiplication. How do you cancel multiplication? You got it. You're going to go ahead and divide 105 to both sides. 315 divided by 105, x equals 3. So now that we got that out of the way, the basics, let's get into some word problems. Last summer, Alejandra took a study abroad trip to Italy. When she returned, she examined her credit card bill and found that she spent 159 euros on the digital camera she bought in Venice. The bill stated that $1 was equal to 0.636416 euros. To the nearest cent, how much did the camera cost in US dollars? Okay, before you stress out here, think about the fact that they gave you. The fact that they gave you here is that $1 is equal to 0.636416 euros. So that's the fact. Okay, they're always going to give you a fact. So the fact that they gave you here is that $1 is equal to 0.636416 euros. Okay? And now, to solve, they're always going to give you one of the values, either dollars or euros, and then you're going to be looking for the other one. So in this particular case, if you notice, they gave you the value of 159 euros. So you put euros to euros and dollars to dollars. So I've got X dollars, which is what I'm looking for, over 159 euros. And there you have it. You have a proportion. So let's go ahead and solve. How do we solve? By cross multiplying. So I have 159 euros equals 0.636416x. You cancel multiplication with division. And when you go ahead and calculate that, which of course you can use a calculator here, x will equal $249.89. There you have it. All right, let's go to another one. On a map, I'm sure all of you have used GPS. This is how GPS works. This is how it calculates the values. On a map, 1/4 of an inch or a 1/4 inch represents the distance of 15 miles. According to the map, Springfield and Brookhaven are 3.5 inches apart. Find the number of miles between the two cities. Well, the fact that they give you here is that 1/4 of an inch, or 0.25 inches, it's always easier to work with decimals in these cases, represents 15 miles. That's my fact. Now, what did they give me? Did they give me inches or miles? That's right, they gave me inches. So you have 3.5 inches over x miles. Go ahead and cross multiply. You're going to get 0.25x equals 3.5 times 15. And that is going to be 45. Let's see. Let's use our calculator here to calculate the value here. And we have got 15 times 3, oh, I made a mistake, times 3.5, and that's going to equal 52.5 divided by 0.25 to solve for x, and x equals 210 miles, because that's what we were looking for. Always make sure you label properly so that you know what your final answer is going to be. And in this case, we were looking for x miles. All right. Number 4. An automobile manufacturer is advertising special financing on its autos. A buyer will have a monthly payment of $16.67 for every $1,000 borrowed. If Max borrows $14,000, find the monthly payment. Okay, so what is our fact here? The fact here is that your payment, you're going to pay $16.67 for every borrowed dollar of 1,000. So you're going to pay $16.67 for every $1,000 you borrow. What are we looking for? They want to know the monthly payment, and they've given us the amount that you borrowed. So we're going to go ahead and we're going to solve this proportion by cross multiplying. So I've got 1,000x equals, when you multiply 16.67 times 14,000, you're going to get 233,380. Divide by 1,000 to solve for x, and x will equal $233.38 as your monthly payment. And that is how they calculate your payments. All right, let's go to a different type. Two figures are similar if their corresponding angle measures are equal and their corresponding sides are proportional. Let's take a little review on corresponding sides. It always goes by the letters that they give you, not by the figure. What do I mean by that? Notice that A, B are the first two letters. That's going to be corresponding to DE. So AB corresponds to DE. Notice the next two letters, BC, they correspond to the next two letters here of EF. So BC corresponds to EF. And then if you notice, the first and the last letter corresponds to the first and the last letter. So AC corresponds to DF. Now that we know the corresponding relationships, let's go ahead and set up a proportion. So I know that 45 to 10 must equal x, which corresponds to 45, over 4, which corresponds to 10. So we're going to head and cross multiply. And we've got that 10x equals 160. So it's, I think it's 180. Let's just verify that. That's going to be 180. Divide by 10 to both sides. And x equals 18. So DE, side DE, would equal 18. All right, let's get to some fancier similar triangle questions. While hiking in the forest, Joel noticed that a bald eagle's nest was at the top of a pine tree. If Joel's 3-foot walking stick produces a 4-foot shadow and the pine tree produces a 24-foot shadow, how tall is the tree? Well, the fact here is that the height of the walking stick is 3 feet, while its corresponding shadow is 4 feet. Now, what did they give us about the tree? The height or the shadow? That's right, they gave you the shadow. So I've got X feet as my height over 24 feet of my shadow. Let's go ahead and cross multiply and solve. I've got 4x equals 24 times 3 is going to be 72. Divide 4 to both sides to solve for x. And that will give me that x equals 18 feet. So the height of the tree is 18 feet. All right, now let's get to some work problems, okay? Please don't stress out about this. It's not as bad as it seems, especially if you follow directions. It's Saturday and Kevin needs to cut and edge the grass. At 9 a.m., Michael asked Kevin to go golfing at 11 a.m. Typically, it takes Kevin 3 hours to cut and edge the grass. When Michael cuts and edges the grass, it takes 4 hours. If they work together, would they be able to finish the lawn and still make the golf date? Okay, let's go step by step here, okay? Let's remember that you always want to identify what you're solving for. And in this case, we want to find how long it will take Michael and Kevin to finish cutting and edging the grass if they work together. So let's go ahead and define the variable that you're solving for. In this case, I'm going to let x represent the time in hours that it takes to cut and edge the grass while working together. Now let's think about the logic here. Write a rational equation using the following logic. Since Kevin can finish the job in 3 hours, Kevin will finish 1/3 of the job in 1 hour. Michael can finish the job in 4 hours, so that means that Michael will finish the job in 1/4. Will finish 1/4 of the job in 1 hour. Therefore, if we add the part that Kevin completes in 1 hour plus the part completed by Michael in 1 hour, you will have the work done together in that 1 hour. So, let's always set up the proper table. In this particular case, we're talking about an event. The event here is Kevin and his work and Michael. We'll just call him Mike. So the rate of Kevin, he can complete it in 3 hours. So he completes 1/3 of the job every X hours. Michael completes 1/4 of the job every X hours. Why are they both X? Because they're going to be working the same amount of time. So remember that rate times time equals work done. So rate of 1/3 times X over 1, if you want to make sure you understand where the numerators and denominators go, the work done by Kevin is X over 3. 1/4 times X over 1, the work done by Mike is X over 4. So now, the work done by Kevin plus the work done by Mike equals 1. Now, let's go ahead and solve. You all know how to do this already. My LCD in this particular case is 12. So I'm literally going to multiply 12 to every single term. 12 times x over 3 equals 4x. 12 times x over 4 equals 3x. 12 times 1 is 12. 3x plus 4x is 7x, which equals 12. And I divide 7 to solve for x. So x equals 12 sevenths, which is 1 5/7 of an hour. So yes, They have 2 hours before they're going to go golfing, and working together, they can complete the job in 1 5/7 of an hour. So yes, they can make the golf date. Okay, next. John and Sally have a pool in their backyard. If they use their hose alone to fill the pool, they will be able to fill the pool in 30 hours. Their neighbor has the same pool and was able to fill it in 24 hours. Suppose their neighbor agrees to let them use his hose. How long will it take to fill the pool with both hoses? So the event. Okay, we're going to put TH for their hose, and I'm going to put NH for the neighbor's hose. What is the rate of their hose? Well, it can complete it in 30 hours, so the rate is 1/30th of the job every X hours. The neighbor can fill the pool in 24 hours, so their rate is 1/24th every X hours. The work done, the rate of 1/30th times X over 1 is X over 30. The rate of 1/24th times X over 1 is X 24ths. So the work done by their hose plus the work done by the neighbor's hose, X over 24, will equal 1 hour of work. So let's solve for X. Well, in this particular case, my LCD here is going to be 120. That's the common denominator between 30 and 24. So I'm going to go ahead and literally multiply 120 to every single term. 120 times X over 30 is 4X, plus 120 times X over 24 is 5X. 120 times 1 is 120. 4X plus 5X is 9X's, which equals 120. When you go ahead and divide 9 to both sides to solve for X, you get that X equals 13 1/3 hours. Now, next, suppose that the kitchen sink can be filled in 5 minutes. If the sink is full, it takes 8 minutes to drain the sink when the drain is left partially open. If the sink's drain is accidentally left partially open, how long will it take to fill the sink? All right. First, the event, to fill and then to drain. The rate of filling the sink is 5 minutes. So the rate is they complete 1/5 of the job every X hours. To drain, remember we're taking away here in this case, so it's negative 1/8 of the job every X hours. Remember that rate times time equals work done. So 1/5 times X over 1 is X over 5. Negative 1/8 times X over 1 is negative X over 8. So the amount that they filled, X over 5, minus the amount that is drained, X over 8, equals 1 complete job. My LCD in this particular case is 40. So I'm going to multiply 40 to every single numerator. 40 times X over 5 is 8X. 40 times X over 8 is 5X, and that equals 40. 8X minus 5X is 3X, which equals 40, divided by 3, X equals 13 1/3 minutes. And there you have it. That's how long it will take to fill the sink, even with the drain partially open. All right. Now, uniform motion. Let's remember, going back in time here, that distance equals rate times time. Okay, it's going to be very important for this question. A plane flies 990 miles west into the wind, so that's going against the wind, and makes the return trip following the same flight path. The effect of the wind on the plane is 20 miles per hour. The round trip takes 10 hours. What is the speed of the plane in still air? Okay. What is my event? Well, I'm going to go into the wind or against the wind. And then I'm going to come back on the return. When I return, I'm going with the wind. Okay? We don't know the rate of the plane, so I'm going to go ahead and determine that x is the plane speed. So the rate of the plane x minus 20, that's the rate of going against the wind, and I have a total distance of 990. Going with the wind, the plane speed x plus the 20 wind that's going to help me goes a distance also of 990. Now, a lot of times people are going to put in a 10 here, but that is wrong. It does not say that it takes 10 hours both ways. It says it takes 10 hours round trip. So how am I going to figure this out? If you remember that distance equals rate times time, and you divide rate to both sides, time equals distance divided by rate. So in this particular case, the time here is 990, the distance, divided by x minus 20. And then the time with the wind is 990, the distance, divided by the rate of x plus 20. So then we set it up like normal. 990 over x minus 20, that's the time it took against the wind, plus 990 over x plus 20, the time it takes with the wind, equals in total 10 hours. All right, go ahead and move this guy here. My LCD in this particular case is going to be x minus 20 times x plus 20. So I'm literally going to multiply that LCD to every single numerator. So let's do it. I'm going to multiply x plus 20 times x minus 20 to every single numerator. Okay, over here on the left, the x minus 20s cancel. When I distribute 990, I am going to get, let's see here, I'm going to go ahead and get 990x plus 19,800 plus the x plus 20s cancel here. So I've got 990x minus 19,800. And that's going to equal 10 times, this is a difference of squares, which will turn out to be x squared minus 4,000. Okay. The negative 19,800 cancels out with a positive 19,800. And 990 plus 990 equals 1980x, which equals, I distribute the 10x squared minus 40,000. Now I'm going to go ahead and create a trinomial. I'm going to go ahead and shrink this up a little bit for myself here. I'm running out of space. I'm going to shrink this up over here. So I have a quadratic. So remember, when I have a quadratic here, and I'm sorry, 20 times 20 is 400, not 4,000. My bad. And then 400 times 10 is 4,000. So now I'm going to subtract my 1980x to both sides. creating a trinomial, 10x squared minus 1980x minus 4,000. I'm going to divide 10 to both sides here, 10 from every single term here, rendering me with 0 equals x squared minus 198 minus x minus 400 equals 0. What times what is negative 400, but when added together is negative 198? It's x minus 200 times x plus 2. Zero product property, x minus 200 is set equal to 0, and x plus 2 gets set equal to 0. So x equals 200 and negative 2. You obviously cannot have a speed that's negative, so the plane speed here is 200 miles per hour. And there you have it. Okay, so now, yeah, we got it. We are done. I wanted the rate, and that is the rate. Now, last but not least, to prepare for a marathon, Carlos ran 18 miles before he blistered his heel, and then he walked 1 additional mile. His running speed was 12 times fast as his walking speed. He was running and walking for 5 hours. Find Carlos's running speed. So let's do our events. We have run and we have walk. The running rate is 12 times as fast as the walking rate. So we don't know anything about the walking rate, so that's x. The running rate is 12x. The time. We don't know the time yet, but we know that he ran for a distance of 18 miles and he walked for a distance of 1 mile. Please remember that time equals distance divided by rate. So my time here is 18 over 12x, and my time for walking is 1 over x. So the amount of time that he ran, which is 18 over 12x, plus the amount of time that he walked, which is 1 over x, equals a total of 5 hours. Let's go ahead and solve. My LCD here in this case is 12x, which I am literally going to multiply to every single numerator. So 12x times 18 over 12x is 18, plus 12x times 1 over x is 12, and 12x times 5 is 60x. 18 plus 12 is 30, equals 60x. Divide by 60, so x equals 1/2. Now please be very careful here. Look at your table and look at what they're asking for. They want his running speed. The running speed is 12 times x. So 12 times 1/2 equals 6 miles per hour, which is his running speed. I hope you learned a lot. Thank you for watching, and practice, practice, practice. Take care now and come back anytime. Bye-bye.